All right, good day everybody. This is the walkthrough for P04. P04, yeah, for the past prac for our assembly, ComSci 3. Really, I'm not going to read through the whole thing again, but effectively what we want to get in this prac is we want to read in two arrays, one input array, one kernel array, and then given these two arrays, we want to calculate an output array. And once we've calculated it, we want to output these things. So basically, we're going to display the cutoff value, the outcome image before cutoff, and the outcome image after cutoff. Now, before I want to start, the best way to approach this is always just to take it step by step. Don't overextend yourself. First, figure out how are we going to read in the values into an array, and then you can rinse and repeat it for the kernel array. Once you've done that, then we worry about the complexity of doing this whole multiplication to get it into an output array. Now, obviously, because we've got three different arrays here, and the instructions were that we are allowed to use global variables for the input image, the kernel, and the output image. I've already created all of these different variables, or let's call it labels in memory. So here I've got an input image array of 16 spaces of D words, meaning it's 16 32-bit numbers that is initialized to nothing. And I've got a kernel here, which is 2 by 2, and which means it's 4 items. And sorry, the input image is obviously 4 by 4, so that's why I need 16 spaces. The output image is a 3 by 3, which means it's 9 spaces. And this one, I'm actually initializing it to 0. And the reason why I'm doing it, I'm going to basically during the calculation part, I'm just adding the numbers together and storing it directly in the output image. But anyway, I'm not going to bore you with the actual labels for the output strings. So let's just quickly start going. In this solution, I'm going to make use of local variables, and as soon as we make use of local variables, I want to ensure that we basically set up our local, we call it the stack frame, and to set up the stack frame, we need to basically store the old base pointer. Now the base pointer is, so the stack frame is a small little window that's on your stack itself. So here we want to make a backup of our base pointer, which is the let's call it the last section of the previous stack frame that our computer used. We make a backup copy of that, and then we set the starting point for the new stack frame, which is basically we move the old stack pointer into the old into the base pointer, and that's our new starting point. And then so this will basically create the stack frame for local variables. And the reason why you get into the habit, so technically, now this is honestly technically in a typical assembly program that only has one long section like this, it's technically not necessary. However, get into the habit of this, it's because as soon as you start creating functions and procedures in assembly, then this is your go-to. At the end of the day, we also want to destroy the stack frame. So let's just do it like this. Destroy the stack frame. And again, this is technically not necessary in the solution because when the program exits, it destroys the stack frame anyway. So, but anyway, we have to do the inverse of what we did up there. So now we move the base pointer into the stack pointer, and we pop the old base pointer from the stack and put it into the base pointer register. Okay, so that basically gets us ready for our local variables, but we still need to make some space for the local variables. And one of the local variables that I'm definitely going to make use of is in our solution, we're going to have to iterate through these things, and we need a row and a column indicators like an R and C to say I'm currently with row 0, column 0, and so forth. So I'm going to create space for that, which means I need at least 2 variables, and these 2 variables I'm again going to use a D word for them, so that's why I'm going to subtract from the stack pointer 8 spaces. 8 spaces, why? Because it's for 2 variables of each taking up 4 bytes. That's a D word. Okay, 4 bytes is 1 D word, and that's why I'm subtracting 8 from the stack pointer at this stage. Now what I normally do is I try to just remind myself how I'm going to reference. So the local variables will be the following. So for instance, EBP minus 4 may be my row. Let's just call it row. So that will be EBP minus 4, and the column will be EBP minus 8. So whenever I want to use, think of this as my own little labels that represents these things. Okay, right. So that's what I'm going to, and how I'm going to reference this. So the first challenge that we're going to have to do is let's just initialize these local variables. Let's do this. Initialize the local variables. Right. So I'm just going to say EBP minus 4, EBP minus 4. Now remember, this is just a little pointer, and it is recommended. Now if I just do that, the question is that a byte? Because this potentially can take up 4 spaces. So it's better to always just say how you're going to fit this in, and I'm going to fit this in as D word pointer. So I'm going to use this as a D word double word pointer, meaning I'm taking up 4 spaces here, and these 4 spaces I'm going to load 0 into them. 4 bytes, that's what I'm basically doing here. If you don't do that in this example, it wouldn't have made any differences because our counters are never going to go higher than 255. But this is just for the nerd in me that wants to make sure I handle all the cases. Now this is obviously initializing column to 0. So this is basically, let's make a note of this. This is row is equal to 0, and this is column is equal to 0. Okay, now let's get some input. Get the input array. Let's make it a nice section in here so that I can clearly see this is where we're going to get the input. And I'm going to send a prompt to the user. Now I'm going to just see how quickly I can do this. Output string, comma, the address of str input address, input array. So I'm basically saying please input array item at index blah blah blah. Then I'm going to give it an open bracket because I want to help the user understand which section or which element. So it's either going to be 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, and so on and so on. So that I'm going to put that in square brackets. So output string, address, str open bracket. Okay. Okay, and now I'm going to output invoke output int the row. So I want to output that. Do I have to do that? I can't remember. If you're not sure, the best is to just try it. So basically got my, so I'm just going to do a create. Okay, so currently it's no syntax errors, and please input array item at index, okay, 0, and then obviously the next is going to be a comma, and then the next thing is also going to be 0, close bracket, colon. So that's what I'm going to do next. So I'm just going to save time, pause. Right, so I've got the basic prompt now going. Let me demonstrate that. Oh man, just save. Right, let's try again. Yep, there we go. Right, next is I'm going to read the input. So, but as soon as I want to read the input, it's going to put that into EAX. Now, potentially, I want to use EAX to help me calculate my array. Now, let's just quickly refresh how we're going to have to calculate the array. So if this is my two-dimensional array, currently I've got this row and I've got this column variables. And the way that we want to calculate this is we're going to represent this in a one-dimensional array. So for instance, if this is the first items in the array, let's just quickly get a few indexes here. 10, 11, 12, etc., etc. I'm not going to draw the whole thing. This is the input array that or the actual array in memory that we've got available. So how do you map this on this? Well, you basically take the first 4 and that goes into that 4. And then you take the second 4, which is maybe that color, and we map it here. And then the next 4, let's make it that color, and you map it in there, and so on. So you have to calculate this given these two variables. So for instance, if our array is 0, 0, the index must result to 1. If it's 0, 1, the index must result to 1. Oh, sorry, 0, 0, 0 must result to 0. 0, 1 must result to 1, and so on and so on. What interesting is, as soon as we get to row 1, that must now be 4. Now, Mr. Maranlal, or the actual prac, actually describes very nicely how you can calculate that. You basically take the row, multiply the number of columns, and you plus the column. So that kind of makes sense. If you just take this as an example, so for instance, if you want to calculate the index of that specific item, this is currently at row 1. Row 1, multiply the number of columns. There's 4 columns in here, so it's 4 plus the current column, which is 0. So that gives me index number 4. So that is the formula that we're going to use. So let's say calculate the 1D array index, which is effectively row multiply by columns plus the column variable. That's what we want to do. So say row multiply the number of columns plus the column. Yep, that's exactly it. Okay, so how do we do this? Well, let's get the row. Well, we've got the row. It is currently in EBP -4, and we have to multiply that with the number of columns. So I'm going to use the imul function here. I'm going to store the answer in EAX. Now, the imul function in certain parameters, you can give it 3, and so I'm going to multiply the dword value pointer. That's in EBP -4. I'm going to multiply that by 4. So take 4, multiply that in here or with that, and store it in there. That should get me this portion of the answer, and all I need to do after this, I add basically the column in there, BP -8. Now, not address, sorry, add. Why does it keep on doing that? Okay, there we go. Right, I don't know if this was actually necessary because this is already a 32-bit register, so it will assume that I'm giving it a 32-bit value. But just to be safe, do it anyway. Then you know that you're using the correct. So this is effectively row multiply by 4, which is the number of columns, or the total columns. And this is effectively then row multiply by 4 plus column. This is the index. Index is equal to. All right, now that we've got the index itself must now be multiplied by the size of the data that we've got. Now, each of these little blocks takes up 4 memory locations. So I have to multiply this index by 4, so which is what I'm going to do here. Again, just going to take this, EAX, 4, and I'm multiplying it in, and there we go. Now I've got this. Now that I've calculated the array, let's now access the array item. So let's say access the array item, or access the array address, because that's what we want to do. So load the effective address. I'm going to load the effective address of the input array, input image, into EBX, and I'm going to add my offset, which I've just calculated from EBX, from here, and I'm going to add EAX into EBX. Now that so inside EBX is currently the address where I want to store my value. So kind of think of this as preparing my pointer, and now we just want to get the input. So I'm getting the input. Now get the input. So invoke input int. After I've evoked this, the answer is in EAX, and I can now store EAX in this location, EBX, EAX. Okay, that should do that. Let's make sure I did not make any mistakes. Okay, 5. And what I can do now is I can also just double check that it actually works, so which is what I'm going to do. Right, I'm going to skip all of this. There's my input int, and I want to just double check that this is in fact correct. So I'm going to use the F4 button to run to cursor. So I've selected this, boop, and it's basically asking me for my input. So let's say 100. Right, so there's 100 in EAX. There it is. And I want to store it in EBX. Now, where is EBX? You can actually see the assembler actually helps me. Well, it shows me what is in EAX. Let's just follow in the dump. There's my memory location set aside for my input array. And as soon as I do that, if I press the F8 button, boom, there's 100 stored in my location in my array. So the next array item will go in there, then the next one there, then the next one there, and the next one there, and so on and so on. That's the idea behind this. Okay, so far so good. I'm reading it in, and let's now put this in a little bit of a loop. Now when you get to this section, I want to basically see whether we're at the point where I can have to loop back to the top. Now, looping back to the top, meaning I'm going to have to actually prompt for this again. So I'm going to just create a little label here. I'm going to call it input loop start. And here I'm going to look at my, so if I go through this, I have to increment my columns and counter. And I will need to look at my column counter, because if the column counter gets to 3, then I want to increment my row counter. If my row counter obviously gets higher than 3, then I have to jump, then I'm basically done with everything. But the column counter basically repeats, blah, blah, blah. I'm going to increment, 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 increment. When the column counter gets to 3, I increment my row counter and I reset my column counter again to 0. So that's what I'm going to do. So the first thing is, let's compare, so effectively this, say if row is, how shall we say it? Just trying to think of a nice way of saying, no, it's column, sorry, it's column. We look at the column. If column is not equal to 3, then we're going to increment the column. Else, we're going to increment the row and set column equal to 0. Okay, so that's what I want to do. So let's set up this thing. Let's compare those two values. So I'm going to compare. Can I do this? Well, let's try. Dword pointer, EBP, the column, remember, was EBP minus 8. Compare that with 3. Then, if it's not equal to, then I want to do an incrementation. Now, let's create a section where I do the increment. So, I'm just going to say increment column, and then, yeah, so this is where I'm going to increment the column. Right, let's say increment column, that's where we want to jump to. Let's just quickly get that right. So we're incrementing the word pointer EBP minus 8. And that once we've incremented that, let's go back here. So once we've taken the column from 0 to 1, we want to start at the top again. So let's just jump to the top. That's a normal jump. The top is input loop start, so that we can again go through everything. So at this point, when we get here, this thing would have been incremented and it will fall down. Okay, now that happens if it's not equal to 3, then we increment the column. If it is equal to 3, then we basically just fall through this jump not equal, because that condition would not have met, so we just basically fall through to the next section. And here we have to increment the row. So dword pointer EBP minus 4, we increment that, and we set this thing, EBP minus 8, equal to 0 again. Pointer EBP minus 8, set that to 0, and then again jump here to input loop start. Okay, right, so this will also go to the top. It will run all of this again. When it gets to this section, it's going to compare the column, and then if it's 3, then it will fall through. One thing which we have to do is we'll have to make sure that we can maybe jump out of the loop. So that's maybe one thing which we have to do. So if both so maybe in here, what we'll do is we'll do another check. So here we've already checked. In this case, if we fall through here, the row is equal to 3. Oh, sorry, the column is equal to 3. What we also want to do is if row is equal to 3, meaning we've basically gotten to the last row, then we want to exit the loop. Okay, if I was then exit the loop. All right, so we're going to do a compare for that, and for that we need to get an input loop end. Let's just call it input loop end. So compare dword pointer EBP minus 4 with 0, with 3 again, and if it's greater than okay, I'll have to just check this just to say jump equal. I'll test it just now. Input loop end. I'm not sure if this logic of mine is now fair. So when I get here, this is where this section is row is not equal to 3, but column was equal to 3. This is what's going to execute here. In this case, both row is equal to 3 and column is equal to 3, this little section here. Okay, let's test this. It's a little bit dear my car. Okay, anyway. Okay, let's see. Input array, item at index, let's say 1. Okay, things are happening. 9, 10, 11, 12, 13, 14. Okay, it's counting well. And I got to the last section, so that's the first row, that's the second row, that's the third row, and that's the fourth row. Okay, it works well. Let's just double check that it's actually going into the memory good, or successfully. So just to save me some time, I'm going to just, after I jump out of all of those loops, I just want to inspect the memory quickly. So this is all part of the whole loop. So you can see this little red arrows actually says, hey, it's going back to the top again. So I think your debugger, for some reason, always gives you nice debugging. But mine doesn't. I don't know why. So I'm just going to stop there. So let's just quickly get some values in again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That should be my last one. Right, so there we go. We're out there. Let's have a look at the array itself. I think the array was in that location. I just want to see that. Ah, there we go. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10, that's 11, that's 12, 13, 14, 15, 16. Okay, that's perfect. That's actually quite nice in memory as well. It's also 4x4 little thing displayed here in the debugger. Okay, let's stop that. Looks like it's nice in memory now. Okay, so this was our get the input array. Now I have to just rinse and repeat this for the kernel array. So let's just do everything basically. Let's go make a whole copy of it, but just be careful of copying and pasting. It's so get the kernel array. Obviously, we have to reset our local variables again. So let's just do this. Set our little loop counters. Otherwise, we're going to resume whatever this was before. So I'm resetting it to 0. This is not the input loop now. So this is the, shall we call it the kernel? Kernel loop start. Yeah, let's do that. And then here we've got kernel loop end. Okay, this is going to jump to the kernel loop start. That is going to jump to the kernel loop start. This is going to jump to the kernel loop end. But we've got increment column here. Okay, let's do this. Let's make this increment column A. It's not a very elegant way of doing it. And this will jump to increment column A. And this will jump to increment column B. Okay, so that's increment column B. All right, so in this case, the kernel is a 2x2 kernel, so it's got 2 columns. All right, so that's 2x2. This you must still, let's multiply. That we have to still multiply by 4 for the get the D word offset. That's the reason why we still multiply that by 4. And this, because it's only a 2x2, we're looking whether the comparison is equal to 1. So that is if column is not equal to 1, if row is equal to 1, row is not equal to 1, but column is equal to 1. and that should get me this. Obviously this is not right. Str input array, str kernel prompt, let's just see. Str kernel prompt, please provide the kernel value, blah blah blah. Yeah, that should do that also successfully. And I need to not store it in the input image, but in the kernel. I think, is that the correct word? Yeah, the kernel. Right. Okay, now let's test that. Okay, at least no syntax errors. Normally when you do this cut and pasting, there's syntax errors, and you have to make sure, be very careful with these jumps. If you don't sort these jumps out, it'll jump back to the top here, and it will just go in. So you have to make 100% sure when you do this whole copying and pasting that you really look at all the labels. Every label that you refer, that you create, must be updated. Otherwise, you will have problems. But anyway, let's get this in. So I'm just going to say 1, 2, 3, 4, 5, 6, 7, 8. You know what? I'm not going to do it here. I'm just going to immediately try it in the debugger so that we can just test it as well. Right, that's the input for the, here's the kernel input. This is where I calculate that. That's where I get the input value. I'm storing it here, so when I get to this line of code, I should be at the end of the input of the kernel. So I've already confirmed that the top section works, so I'm just going to jump to cursor. That's F4. 1, 2, 3, 4, 5. Okay, I missed 3 there. 13, 14, 15, 16. 17. Okay, so now this, so the input kernel is interesting. You typically don't want to have too many big values there, so I'm just going to put a bunch of 1s in there. Right, let's have a look at that memory. So the input or the kernel is in, you'll see that here's the address of the kernel. Here's the address of the input array, and they're normally in the same-ish area of your memory. So sorry about that. That's not what I want to go to. Okay, I don't know how to get back to the, okay, let's just do a step, maybe that'll, okay, here we go, I'm back. Following dump, constant, there we go. Right, so there's my the 4 ones that I've added, and this is my previous array. There's my previous array. This is my kernel array, and this is most likely my output array. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my output array. So that's my 3x3 output array. That's all good, and it looks fine. All right, stop this. So now I know I've successfully handled the input of these 2 arrays. Now comes the difficult part. I have to now go and do this. Now, you first have to understand how that works. So what I did was, just to help me, I first created a little Excel representation with some dummy data in, because I wanted data so that I can, potentially when I debug this, I can actually see whether the data makes sense. So here I've got my input array. I've got my kernel, and then here's the output array. Now the output array is effectively this little formula. It takes, let me try to zoom in there. It effectively takes H2, which is the kernel value, multiplies it with the, because it kind of maps the kernel on this section, multiplies it by that, and then it's going to add 1 multiplied by 220, and then it's going to add 1 multiplied by 80, and then it's going to add 0 multiplied by 70, and then the answer in this case, because those 2 are 1s, it's 220 plus 80, which is, if I just do a quick, that's going to be 300, and that's why you'll find Excel gives me a value of 300 there. and this is the 251. So again, if I look at that details, it's these 4 little blocks mapped against this 4, and that's how it calculates. Now, you can do this, I think, easy-ish, or you can play it hard. Now, unfortunately, I tried to do it difficult. So I just want to quickly show you, this is how I solved the problem. Let's get rid of this. Let's sort of put this to the side. Just to show you, for now, I'm just going to put it here at the end. Okay, effectively, I'm looping, I've got 2 loops. I've got 2 for loops, 2 nested for loops. So I've basically got a for loop that's going to go to each of my output image indexes. So basically starting at 0, 0, then 0, 1, then 2, 1, and so forth. So, and in my example, I used the following little principle. So I said int, and I said, what did I call it? I just want to make sure that I use the same things. I call it row offset. So it's probably not the correct word. And I initialize that to 0. And I say while row offset is less than 3, because it's a 3 by 3 array, then row offset plus plus. Right, so that's the outer loop. This is good. So this is effectively going. I'm going to try and iterate through this 2-dimensional array. So I'm setting the row little variable, and I'm setting the counter of the column variable. And the reason why it's a 3 by it is 3 by 3, but effectively what happens here, and this is also why it's also 3 by 3, is the first iteration you're looking at that section of the matrix. And then the next iteration you're going to look at that section of the matrix. And then that section of the matrix. That section of the matrix. Okay, so that's the so that's 1, 2, 3. And then we're going to do the same there. And then the same there. And so on and so on. And that's why I'm using the word offset, because I'm going to use the offset to calculate which section of my 4x4 array is in here. So for instance, this guy, if I want to calculate this guy, it's effectively these 4. If I calculate this guy, can you see we're offset 1 in the column? So that means I'm going to go here, and I'm going to use from the input array also column 1. And if I want to go there, this is in column 2. That's from the from input array 2. The input array I'm also going to use from column 2. And then I'm going to use you'll see now, an offset, these 2 variables to help me calculate these different offsets. But anyway, so a bunch of words offset, that's why I've got it. Anyway, int column offset 0 while column offset less than 3, column offset plus plus. Right, let's just see the syntax errors. Yeah, I did make there's a spelling mistake. Okay, that's fine. So this is my outer loop. Now effectively what you can do here is you can really just using plain simple, so if you want to calculate the actual from the input array, you basically will go row offset is the first array item, comma row offset. So that's the item in the input array that you want to work with first, and you're going to add that to maybe the row offset, comma, why did I say column offset? Column offset plus 1. Okay, that's and then the second guy is row offset plus 1, comma, column offset. That's the third one, and the fourth one is so on and so on. But I decided, for some reason, to make it even more complicated. I actually created a small little inner for loop here, and for that, that's why I want to just take my original little thingy back, so I can explain to you what I did. I actually created an inner for loop as well that iterated through those little, let's call it the kernel portion of it. So it's effectively iterating through each of these small little items and then iterating through the 4 of that. So I've got a 2x2 a loop that loops for each row and column in that sync, and an outer one that does the 3x3. Okay, and just to show you, this is kind of how it looks like when I print it out. So the reason why I print it out this way, oh, there we go, is it shows I'm going to take that item in the input array and I'm going to multiply it with that item in the kernel. Then I'm going to take the item, adding that item in the input array, multiply that item in the kernel. That's input array, that's the kernel array, input array, kernel array. Then the input array changes, now in column 1, and that's the kernel array. Input array, kernel array. So the kernel arrays always stays the same. Can you see 0, 0, 0, 0, 1, 0, 1, 0. But the input array changes after each section. So it's the starting little for block changes its top left corner after each of the iterations. Okay, so with this in mind, I've got four loops here. 1, 2, 3, 4. And the advantage of using this method is you can create an n-dimensional kernel, and you can also create an n-dimensional input array, and it will work. All right, where if you just did the normal +1 plus that, then it's fixed. Okay, so with that in mind, how do we go about doing this? So let's just get a whole section here. Let's call it store the, or calculate, or let's say apply the kernel. Sorry about that, I'm wasting your time. All right, now how do we go about getting this for loop going? Now to help me with this, I'm going to take this and I'm going to put it in my code as comments. So I can actually visually look at it while I'm building my solution. Obviously the outputs I don't need. But anyway, right, so the first thing is I want to set up this outer loop. For this I'm going to need a row offset variable, which I don't have anywhere yet. So let's create a row offset variable. And I'm going to have to create a column offset variable as well. So, oh, and before that, I also need to get a cutoff value. So, all right. So there's 3 more values that I'm going to create here. And for those 3, that means I'm going to have to make space for 3 more. So to make space for 3 more, so that was for 2. I need, so that's 4, 8, 12, 16, 20. I need to make space, subtract 20, and then I'm going to, let's just make note of this, here. I'm going to say offset, is going to be in EBP minus 12 for a 12 here. And then I'm going to say, what is it, row, is it offset? No, it's cutoff. Sorry. My brain is now just a row offset. That'll be in EBP minus 4812 16. And then column offset will be in EBP minus 20. All right, so that's the local variables that I'm going to use here. And I've just made space for them. So now I know I can use row offset and column offset, and just want to make a note of that closer to my code as well. Because otherwise, believe it or not, you actually forget where these things are. And I'm just going to make note of this as well, because I'm going to need the row and the column. Let's get that. Okay, right. Outer for loop. There, I have to set that to 0. So let's go ahead and set that to 0. In fact, I can set everything to 0. Row, column offset, everything. All of that will basically be set to 0. Yeah, why not? Let's just do it. Move EBP minus 4, comma 0. So this is, actually, you'll see now, I need a few more tabs here. So this is row is equal to 0. EBP minus 8, comma 0. This is column. Let me just get this in quickly, just to save you some time. Okay, right, so I've got the 4 local variables that I'm going to use initialized to 0. Let's get a little label here, and I'm going to call this label outer row loop start. So it's that row loop, and that's the outer portion of it. Let's get that, and as soon as I do that, I've already set the row offset here to a 0, so that's all good. Next is I have to check that, so while row set is less than 3, so I'm going to compare row offset is that guy. I'm going to compare that to 3. Okay, so basically saying if row offset, and I'm basically going to say if it's greater than or equal to 3, then jump to the end, then exit outer row loop start. So that basically means I need a outer row loop end. So if it's greater than, meaning if my little counter for all the rows that we've now got, if it's more than that, more than 3, we've basically got everything, and we need to exit this jump greater to outer row loop end. Okay, now I'm ready for to get this going. Now, before I get this going, before I jump into this, when I do the outer loop, this variable is going to change. Row offset. Row offset is going to increment at some point, blah, 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 the whole time. No, I haven't, I'm not done yet, sorry. At the bottom here, I'm going to have to, before I jump out, I'll have to increment my column offset, but it's effectively right before this part of it. So it's increment that. That is equal to that section there. So after each of the loops, so when I get to the bottom of this loop, I have to increment row offset, and then I'm going to jump back to the top. Outer row loop start. So this kind of sets my little for loop, this little thingy. Actually, what actually goes hand in hand with that is initializing that. So I'm just going to move that here so it's close by, because that's actually part of the for loop. You have to initialize your first variable, which is row offset to 0. Then you're going to compare row offset less than 3. That's what I'm doing here. If it's greater than, go to the end. When you get to the end of the loop, I'm incrementing it and I'm jumping back to the start again. All right, now the next section is my outer column loop start. And I'm going to use the same structure. I'm going to use an outer column loop end. Right. And when I get to the outer column loop start, when I'm in here, I again have to compare. Oh, you can't start yet. I have to reset. Column set is equal to 0. So let's just move that. D-word pointer EBP. Which one is the column? That's -20. 0. And then I can compare this. Compare that with 3, because that's the 3 there. And then if that is equal to, jump greater than equal to, outer column loop end. All right, that's what happens there. And then when I get to the bottom here, I have to increment D-word pointer EBP -20. And then I have to jump to the top again. Outer column loop start. So this thing jumps there, and I'm going to rinse and repeat until that thing gets to greater than 3. Then I'm going to jump out, and then I'm back in my inner part of it. Okay, now that I've got that, let's just stop right there. Let's just make sure that there's no syntax errors. Yeah, there is. 170, there's a mistake. Outer row loop end. What's the mistake it says? Oh, I should use a colon. Outer row loop 158. Okay, so that should fix that problem. I had a semicolon there instead of a colon. Okay, that looks good. So no syntax errors. Okay, now I basically can do the inner row loop. So I called mine inner row loop start. But before I do that, I have to initialize my variables, and I do the inner row loop end here. So let's just get the variables correct. So D-word pointer, the inner variable is EBP minus, that's the row, is -4. Set that to 0. And in here, I'm going to do a compare whether that variable. Now this is the inner loop. For this, I only have to loop twice. So if, which means I'm actually checking for 1. Oh, I'm looking for. It's less than 3. That should be less than. Yeah, no, this is correct. So I have to look that twice. Okay. If that happens, jump greater than or equal to the inner row loop end. Good. Then before I loop to the top again, I have to increment this thing. And I jump to the top of this loop, inner row loop start. Right now here is my inner column loop start. It's this little column loop. And inner column loop end. But before I go into that, I have to set my column to 0. So it's effectively the same as that, except that this is base pointer -8. There you go, that's for column. And then I do the compare. That. So basically compare that to 2 as well. And if it's greater than or equal to inner column loop end, and then I'm sorry about this. I have to increment that. And I have to jump to inner column loop start. Okay, here. Okay, right. So this is this very complicated loop start. So here I'm going to first get the value from the input array. Then I'm going to get the value from the kernel array, and then calculate and store in output image. Sorry, this is actually the input. Did I say input array? Input image, actually. Anyway, so this is basically the steps that I'm going to take now that I'm in here. Okay, so the input array, this is where things get a little bit tricky. I have to get that item in my first iteration. Oh, that item, and then that item, and then that item, and that item. But in the as soon as my output array, or in the next, if I want to calculate that guy, I'm going to have to use these 4. So, and this will be the values. So that's why I'm using this offset principle. Okay, so let's get those values. Let's see if we can make sense of that by using this as a guideline. So basically I have to calculate that as the row offset. So first get the actual row value, and then the column value as the 2 indexes. And then from the indexes I have to again calculate its offset in the one-dimensional array, and then that's the challenge that I have here. Okay, so let's just do this. I've got this. So I have to do row multiplied by 4 plus the column. That's kind of the thing that I have to do, but the row you have to, it's a row plus the row offset, which I'm going to have to calculate, that plus, and I have to also do the column offset here. See there, column plus column offset. That is the actual thing that I want. So the row value is in EBP -4. So let's put this in EAX. Let's get it into my accumulator. To dword pointer EBP minus 4. That is the row. Now I want to add the row offset there. So that I can just do this, add into EAX. EBP minus the row offset is EBP minus 16. Now I have to multiply that by 4. Okay, so that multiplies it by 4. That gets me my row offset, and that is in EAX at the moment. So let's just call it R. And basically, so if I say this, R is equal to that, then R is basically going to be, I'm going to use EAX for that. Now I'm going to do the same, but for the column. So it's effectively that. Sorry, I've only done that part of it yet. So now I have to do that, but I have to store that somewhere for now. So for now, I'm going to put that into EBX. I probably can use EDX as well, but IMAL does weird things, so I'm going to store it in EBX. Dword pointer EBP, that the row, the column is minus 8. And the row offset is in, I have to add the row offset of the column offset now, which is in EBP minus 20. Okay. Now I've calculated that, so basically that I've got. Now I have to take this and add it together. So let's take that and make a note of that. So I add EBX to EAX, which is effectively adding that to that. All right. Now that I've got that, I have to calculate the memory offset in my array, which is effectively just EAX with 4. Multiply that by 4, and now I can add this to my base address of my output array. We get the base address of the output image. So load effective address, put that in EBX, output image, and then I add the offset that I've just calculated into EBX, and now I can store that answer. Now, this is the input image. I need to get the input image here. It's not the so input image. So I get the base address of the input because I need to read in the value of the input array. Input. Okay, now let's store that value from the input image somewhere. Which register haven't I used yet? I haven't used ECX yet, so I'm just going to store that into ECX. Okay, so this basically stores the value from the input array into temp variable. The reason why I need to do the temp is, remember, you have to take this thing and multiply it at the end of the day with whatever is in the kernel. Right, so this is the input array. Now get the kernel value. And again, it's effectively this. I'm going to have to go through this, except for the kernel, you don't do the offset. So I'm just going to take all of this and just going to modify it for the kernel. The kernel, well, still get the normal row. This is EBP, but there's no row offset here, so I don't have to worry about that. Now I get the column. Don't have to worry about that. So it's not row offset, it's just that. And the row offset I don't need as well here. So it's just row times 4 plus column. That's what I'm doing here. I calculate the memory offset. Now let's get the value that is in the kernel. So load effective address, EBX, comma, kernel. And now I add EBX, comma, EAX. So remember, our previous value is temporarily stored in ECX. And now all I do is, let's store the answer that was in EBX there. So store the kernel array item in accumulator. So we finished working with EAX, that's why I can overwrite it. And now that I've overwritten it, I can, I've got the answer in kernel, I've got the answer in my input array. I can now do the multiplication. So all I do is I mul EAX, comma, ECX. So this is effectively what shall I say? Input array, row, column, multiply, kernel array, row, column, well, that is plus offset. Okay, so that's what happens here. I multiply that with this. And now that I've got the answer, I have to store it in the output array. So the output array is a 3x3 array. So I think, how will I do that? How do I know? Sorry, I just want to check this again. Oh, the output array. It's because it'll do it nicely. It is 3x3. That'll work nicely. Yeah. So I can just store the answer. Let's get rid of this. Okay. So again, I need to get the address of the output array. So here, I'm going to need the row offset because it's the output. It's effectively in the output array. I've got, I should have called it the outer, I shouldn't have called it the row offset. This is the output array row effectively. So effectively I need to get this thing and I need to get that thing. That will give me the address of my row and column of my output array. Okay, so it's effectively this. So get the row value of the output array, which is this. And I'm going to move that into EAX. D-word pointer EBP, I called it offset, so it's minus 16. So that's the row offset variable. Now I use the same idea here. Row offset minus multiply by, in this case, it's a 3 by 3 variable array. So imul EAX, 3, and now I have to add the column offset. So it's effectively now row offset multiplied by 3 plus the column offset. Okay, so this is now just add EAX, D-word pointer minus 20. Let's just do it a bit neater. I'm going to put it here. Okay, so that will do that. Now that will give me the okay, and obviously that's the index. And then imul EAX, 4, convert to memory offset. Well, memory spaces, whatever you would like to call it. Now I can get the address, load the effective address of my output image, put that into EBX, add EAX to EBX, which is the address of the item that I want to now store. And now I store the value that I calculated here. Oh, and now I've overwritten. Okay, so let's just store this away quickly because I'm reusing EAX. So move CX, EAX. Temporarily store the answer in ECX. And let's go add. So I'm using the add because it really just, each of these, let's do this, sorry, each of them gets added together. So it's, if you zoom in there, I've basically calculated that, and then I'm going to add the next one. And then I will calculate the next in the next loop and add that there. And then calculate the next one and add that there. So that's why I'm adding these things together. And I think that should be it. So it's effectively this. It's the output array. Output image, row offset, column offset is equal to, or plus equals to, the input array, row, well, that thing that I calculated there on top, column, plus the kernel, row and column. Obviously that is also the row offset plus row offset plus the column offset. Okay, so that's what gets added in here at the end of the day. And that should do it for getting the values in. Now again, what I can do is I can quickly just check this in the debugger. So let's do that. And then I'll do the output. Okay, there's a 186. 186. input image. Okay, I'm going to use my actual values that I've got here so I can verify the values that's stored. So 200, 220, 180, 200, 80, 70, 60, 50, 40, 30, 35, 25, 10, 0. Okay, the kernel 0, 1, 1, 0. Okay, that looks all fine. I did not do it in the debugger. Okay, believe me, we'll test it out just now. Okay, so next step is we want to output all of these things. So I'm just going to say, I'll worry about the offset just now. Output the output image. Right, and this I'm going to again use this principle that I had here on top. Effectively this, but I'm going to use it for output purposes. So in this case, it's not the kernel or anything. Output the output array. So it's, what shall we call it? Output loop start. Okay, then at the bottom there should be output loop end. Okay, this should be output loop start. Oops. My goodness. There's so many of these things. This is output loop end. Then I've got this label. Let's make that a C. And this is the output image. I'm going to load. The output image is a 3 by 3 thing. This is not going to work, so this I have to remove, because once I get the value, then I can output the stuff. Right, so here I'm going to get the value. So basically, got everything. Let's read the value from EBX. There I'm reading the value. This is the get the value from the output array. And this is multiplied by 3, obviously, because it's a 3 by 3 loop output array. Now that I've got the value in the output array, I can output that. But let's get, yeah, I'm just going to output it. I'm not going to make it look nice. Output string, output int, EAX. Let's get a comma in here. Output string address str comma. And let's put a tab as well, although it's probably not necessary, but I'm going to do it anyway. Str tab. Okay, so at the moment, all of this will be output on one single line. However, when I output loop start. So I think, when do I want to put a new line? So I'm going to put a new line in here. Output string address, str new line. Because remember, this section of the code will only run if we've finished with the row. So that's why I want to put it in here. Then we'll go to the top, get the new row done. And if I want to, just after all of this, I'll just put another new line. Okay, so for now, I just want to do that. Let's just see if it works. 250. Output int. Okay, just want to get my values again. 200, 220, 180, 200, 80, 70, 60, 50, 40, 30, 35, 25, 10, 15, 5, 0, 0, 1, 1, 0. Oh, okay. What is it doing? That is not right. Okay, let's just figure something out what happened here. Okay, I just spotted a mistake. This is the kernel sections, and the kernel is only a 2 by 2, so don't multiply that by 4, multiply that by 2. That's one error. Let's see if there's anything else I can spot. Right, in my output array, when I output my image, for some, I didn't take out this code, which is obviously incorrect. You can't get input again, so you have to remove that, which is probably why my code did some weird stuff. Let's see if this now sorts it out. I just want to get my values again. 200, 220, 180, 200, 80, 70, 60, 50, 40, 30, 35, 25, 10, 15, 5, 0, 0, 1, 1, 0. Okay, that is good. It actually, so here's the real answers. 300, for some reason it output only that. 250, 90, 110. I think my for loop for outputting that is not 100% right yet. Which is what happens here at the bottom. Oh, yeah, it's because that is comparing that to 1, and I need to compare that to 2. There we go. That should fix that. Right, now that's not all. This is my output image. So I'm going to just output the image. I'm going to output that str output before. And the next is I still need to get the cutoff. So I have to build that in somewhere as well. Let's store it up here before I actually go and get this. Get the cutoff value. So invoke output str address str cut off, then get it, and then store that. No, store is just like this. Move keyword pointer That's not necessary. D-word pointer in this case is not necessary because it's just already a register of 4 bytes. So that's an EBP. What's cut was 4, 8, is it 12? Cutoff is 12, EBP minus 12, yeah. So minus 12 or EAX. Okay, so I've stored that. Now let's just get a little bit of a image here as well. Invoke output str, comma address str output before. Okay, that will output before. And now I'm going to rinse and repeat this thing to output the array, but this time after the cutoff. Output the output image after cutoff. Output after. So output loop. What shall I call this? Output loop start A. Output loop end A. End A. Column D or okay. Right, so in this case, all I want to do is I'm going to get the value of EAX and I'm going to compare that value, and if that value is greater than the cutoff, then I want to output a 1. If it's less than or equal to the cutoff, then I want to output a 0. Okay, that's really what I want to do. Let's just see all the labels. Looks like I've got all the labels. I will probably quickly see if something weird goes on if not all the labels are there. So I'm not going to print out that, but let's see, if, let's say, output row column is greater than 0, or is greater than cutoff, then EAX1, else EAX is 0. Okay, that's what I'm going to do. So let's compare that with that. Now let's just first get one of these guys in. I've already got it in EAX, so I'm going to compare EAX with dword pointer EBP minus, what was it, 12? 4, 8, 12, yeah, it's 12 is the cutoff, comparing that, and then I'm going to say if it's, well, why not, jump greater than or equal to, so I'm just going to make it greater than or equal to. I have to put some label here. Let's see if there's maybe a more efficient way. No, there's not an efficient way, so I'm just going to call it greater than. And I need a label here at the bottom so I can jump out. I'm going to say right value. So this is super boring, today's walkthrough, sorry about this. So this will jump to greater than. If it's not greater than, then I'm going to move EAX to 0. So I'm basically doing the else there. If it's greater than, then jump to right value, else move EAX to 1. And then write that. Let's try again. $200, $220, $180, $200, $80, $70, $60, $50, $40, $30, $35, $25, $10, $15, $5, $0, $0, $1, $1, $0. The cutoff value, let's say it's 100. Okay, something's not right, but that looks correct. That looks fine. Let me just confirm, show you guys. So there's my output array, what it's supposed to be. 300, 250, 260, 110, 90, 85, 40, 50, 30. Now technically those things had to be ones. That should have been a 1, that should have been a 1, that should have been a 1. Okay, let's fix that. So there's something in this section of the code that's not right. Getting the value here. Let's just confirm, was it EBP minus 12? Yeah, that's definitely EBP minus 12. Write the value. Oh my goodness. Finger mistake. There we go. Okay, that will fix it. I'm not going to run the code and waste your time. So the only thing that's left is the loop. Let's call it the loop until the user quits. I'm going to just take the code that I've used in my previous pracs, and I'm just going to reuse that. So I'm not even going to, I'm just going to copy it. Right. That'll loop until the user quits. Okay, you can have a look at this code again, not to waste any more time. Thank you very much. Have a good day. Bye-bye.